Hi class, welcome to chapter 8, using special calculations in compounding. In today's video, we're gonna go over compound formulas. We'll review the other topics in the next videos. Our learning objectives for this video is to calculate the amount of each ingredient needed to enlarge a formula or recipe, and calculate the amount of each ingredient needed to reduce a formula or recipe. So compounding is the process of using raw ingredients and/or preparing ingredients to create a medication for a patient. Compounding usually involves both active ingredients, compounds that provide a pharmacological activity, and inactive ingredients, compounds that do not affect pharmacological activity. So again, basically the active ingredient is the drug that's going to help our system to get better. And the inactive ingredient is just some additives that they've added, like, for example, in children's medication, some kind of syrup that will taste better for the child to take the medication. Or in the case of pills, you have the inactive ingredient would be the capsule or the shield of the tablet. Anything that is not going to produce any harm, basically, hopefully, in the system. The process of compounding is similar to making a cake from scratch by using ingredients such as the batter, the sugar, the eggs, the flour, and baking powder. So compounding is regularly done at special compound pharmacies, but is also done in institutional pharmacies. Some community pharmacies also engage in medication compounding. So again, compounding is just basically like following a recipe. You're going to get all your ingredients. You're going to measure everything that you need for that recipe, and you're going to mix it. So like we just read, compounding, there are special pharmacies that do compounding. They have a special license. And you do some type of compounding in hospital settings or convalescents where the patients are admitted into the hospital or things like that. Some community pharmacies like Rite Aid, Walgreens, and stuff like that will engage sometimes in compounding medications, but again, this is not common. It is done, and occasionally for if there's one patient specifically, if you need it for more than 20 patients, then the rules state that they cannot do that. So the patients either have to go to a specialized compounding facility that is licensed or get their medications through the hospital. So a compounded medication is prepared using a formula or recipe, like I stated before. The formula is written document prepared by a pharmacist that lists the ingredients and instructions needed to prepare a specific compound. Some formulas are intended to prepare a single prescription. Others are intended to prepare a compounded stock preparation, or a larger amount to be divided and dispensed for individual prescriptions ordered later. So again, we fall into the rules and regulations that you cannot compound for a multitude of people, but you can compound enough medication to prepare in advance to help a couple patients, especially when the compound medication is not available commercially. Then you're able to go ahead and compound enough for either an outbreak or something. A good example would be during the flu season. Tamiflu is a medication that is prescribed to a lot of people, and sometimes the manufacturer does not produce enough medication, especially for children. So in instances where I worked before in the hospital setting, we're having to compound that medication that we have in tablet form, into syrup for children that come into the hospital with the flu. The Tamiflu, the stomach flu, that's what it's used for. Compounded ordered compounds can be made in advance. Compounded sterile preparation is a product made by mixing one or more sterile products using aseptic technique. Aseptic technique is a method designed to prevent or minimize the risk of contamination. So if you've learned hopefully about sterile compounding already in pH 108, you should have learned that also in 140, and you might have hinted at it in 120. So again, it's just preparing the medication where hopefully nothing is contaminated while you prepare the medication. So your area has to be sterile. You might wear gear to mix these type of medications. So again, it's very important that you do not contaminate the medication. There's been outbreaks of a couple years back of even in manufacturer settings where something happened and the some of the medication got contaminated, and I believe it killed a couple people. Not that much. I think it was only 6 people, but 6 people is enough. So you have to be very cautious whenever you are compounding medications. It's very important that you follow these rules of keeping everything sterile because you can harm a life. So be very cautious, follow the rules about the way you dress, about when you're preparing, follow each step accordingly. If you don't know how to measure something, again, make sure you ask for help, because again, this is very crucial information that you have to follow. You are risking people's lives, hopefully, and you're doing the best you can, of course. So ask for help if you ever need it. So some pharmacies routinely compound preparations for physicians who prescribe these special preparations on a regular basis. A pharmacy that prepares these compounds will often have a recipe for making a large amount to have on hand. Preparing large batches is sometimes referred to as batch compounding. So again, sometimes you'll have these outbreaks and you have to prepare enough to help each individual person. So that's where the compounding batching comes in. Preparing compounds in advance can result in cost savings by reducing the labor needed to make the product, and can also save time in providing the compound to the patient. Again, this preparing in advance does help whenever there is an outbreak, but then again, you have to be cautious as well. For example, the Tamiflu example that I gave earlier, if we produce a lot of it and not enough patients come in for it, then you're also risking cost. So it's very important that you pay attention to how many patients are coming in with that need Tamiflu, and make enough to last either for the week for a certain amount of people or last 3 days, depending on how many people you're getting into the hospital. And again, the Tamiflu in liquid form is not available for pediatric patients. Although the Food and Drug Administration prohibits retail pharmacies from mass manufacturing compound medications, anticipatory compounding is permitted in small quantities. When a particular pharmacy is located near a physician's office that routinely orders certain compounded prescriptions. So sometimes there will be either patients that can't go to the hospital because, again, it's cost and stuff like that. So the physician might prescribe it from the local retail pharmacy. For example, we did have a patient that come in that was their nutritional system was not very good. So they needed to come to the hospital 3 times a week to get what we call a TPN, so a total peritoneal nutrition. So this person was malnutritious, and so they needed this medication 3 times a week. And again, this is too much costly for the patient. So the physician decided to go ahead and send that prescription to the local pharmacy. And again, because of the FDA, were able, that retail pharmacy was able to go ahead and compound this medication for that particular patient. And it was less costly because, again, um, they didn't need to have a bed, they didn't need to have that nurse. I started an IV, and of course, hospital things get very expensive. And the person was able to go ahead and take that medication to their home, have uh, those nurses that go to the house administer the medication and stuff like that, which is less cost effective. So pharmacy stores formulas in many ways. They may be maintained using a computerized file system or informally in a card file or a binder. So again, we have to have these formulas, or what we call recipes, ready in the pharmacy for these type of sometimes outbreaks and stuff like that. So the pharmacy says a formula is often called a pharmacy recipe book. Excuse me. Some pharmacies also have different formulas for different prescribers. Each prescriber may prefer a slightly different versions of a particular compound. So again, not necessarily that the prescribers like a different version of it, but sometimes it also has to do with the patient itself, the patient's weight, the patient's age, patient's height sometimes has a lot to do with it. So there might be that that particular patient might need a different strength in that formula that is not commercially available. And we see this a lot also with chemotherapy medications, that again, it's depending on the patient, their type of cancer, it's depending on the patient's body mass index. So these medications may vary time to time, and then therefore the pharmacy has to make preparations for that type of things. So enlarging or reducing formulas involves taking the recipe for a particular compound medication and adjusting the amount of ingredient to meet the needs of the pharmacy order. So again, these adjustments are based. So if the medication is, the recipe is for 100 patients, but you only need for 20 patients, you're going to have to reduce those ingredients to meet 20 patients. Or if the recipe is for 100 patients and you actually have a big outbreak and you need it for 1,000 patients, you're going to have to accommodate that recipe to meet those 1,000 patients. So we're going to have to follow some things that we need to do in order to meet the needs of whatever the medication is needed for, the amount of patients that it's needed for. This practice is similar to doubling the ingredients in the recipe for cookies to making twice as many cookies, or retaining the correct portion of each ingredient in this process is critical. The cookie made from a double batch should have the same ratio of ingredients as a cookie made from a single batch. The same must be true when a formula is doubling a compounded pharmacy. So again, like I was stating, so if you're making enough for cookies, let's see, there's the recipe calls for 12 cookies, but you need double, you need 24 cookies. So you're going to add the ingredients to meet those 12 cookies that you need to batch. The same calls for compounding medication for 100 or 1,000 patients, or 20. It is essential for pharmacy to maintain accurate records and documentation of mathematical calculations used in reducing or enlarging the formula. Just like you have that recipe book, you will also have a compounding book in the pharmacy, and those are part of the rules and regulations. You need to have that information available if you ever get audited by the Board of Pharmacy. So you need to have that calculation book readily available with all the ingredients that you use. So you will calculate the amount you should have calculated, the records before the weight, measuring, or mixing, and the final prepared products must match the concentration, also referred to as the strength or the percent in the amount ordered by the prescriber. So all this information needs to be calculated, needs to be recorded in that book. You will record the medication's name, the lot number, the strength, the manufacturer, how much of the medication you use. So you'll have the original recipe, and then you have the calculations as if you increase the volume or decrease the volume. You'll have the calculations entered there, and then you'll have what the final recipe called for to meet the 20 patients or the 1,000 patients. So to accurately compound a prescription, the pharmacy technician must locate the current formula, which is the formula that is kept on hand in the pharmacy recipe book. Excuse me. In addition, technicians will need to know the desired formula, which is specialized pharmaceutical recipes ordered by a prescriber that alters various compounds of a current formula. So again, as a pharmacy technician, you need to go into that recipe book or pharmacy recipe book, locate the correct formula for the correct medication, and then make your calculations as to if you need to increase or decrease the ingredients for measuring the medication. Compounded formulas often include the abbreviation QSAD. QSAD is an abbreviation for Latin terms quantum sufficient ad, which means a quantity sufficient to make. So QSAD almost always refers to an inactive ingredient in the formula. It instructs the preparer to use an ingredient up to the specific quantity. So if the recipe calls for a quantity sufficient to make 100 mLs, you'll measure the medication. So if it's a 30-gram medication, you'll measure that medication, you'll weigh that medication in mLs, and then you'll add whatever the inactive ingredient. So if 30 grams weighs 2 mLs, that means you're going to have to add 98 mLs of the inactive ingredient. So that's what QSAD stands for. So for example, suppose you are preparing 100 millimeters of a compounded medication that contains 2 ingredients, one active and one inactive. So the formula calls for 5 grams of powder from form of the active ingredient. The formula also instructs QSAD 240 mLs of inactive ingredient, which is a liquid. So you're going to have to prepare your first measure of 5 grams of the active ingredient. That would be then added a sufficient amount of inactive ingredient until the total volume of the compounded medication was 240 ml. So the volume of the inactive ingredient you would add is actually less than 240 ml because the formula makes 240 ml total, and the active ingredient makes up volume. So again, if 5 grams of this active ingredient actually weighs 2 mLs, that means you're going to have to measure 238 mLs of the liquid to make a total of 240. Hopefully you kind of understand what this QSAD stands for with this example. So let's go. A prescriber has ordered a patient to receive 100 ml of commonly used topical iodine solution. The pharmacy recipe book lists a formula to prepare 1,000 excuse me, of the solution. So determine how much of each ingredient would be needed to prepare 100 ml of solution. So here you're going from the recipe calls for a large amount, which is 1,000 ml, but you only need a smaller amount, which is 100. So you're going to have to divide. So determine the ratio to prepare the desired formula with the current formula. So the desired formula requires for 100 ml, and the current formula is for 1,000. So you're going to get the ratio of the two. So the desired formula would be on top on the numerator, so 100. And the current formula, what you have is going to be in the denominator. So 100 divided by 1,000 gives you 1/10. Therefore, you will need to divide everything by 10 in order from your current list in order to get the correct amount of medication that you need. So step 2 would be to again, you're going to write in that compounding book the current formula for 1,000 ml. It has iodine 30 grams, sodium iodine 25 grams, and purified water quantity sufficient to 1,000 ml. So now you're going to write that down what you actually need. So the desired formula is for 100. So what did you do? Iodine 30 grams divided by 10, because we have a ratio 1/10, is equal to 3 grams. So you're going to measure 3 grams of iodine. And the sodium iodine, you have 25 grams divided by 10 is equal to 2.5 grams. And then the purified water, 1,000 divided by 10 will give you the quantity sufficient of 100 ml. So you will need to add 3 grams of iodine, 2.5 grams of sodium iodine. You will also need enough water, purified water, so that the final volume is 100 ml, because the desired volume indicates that it's a quantity sufficient to make 100 ml. So the following pharmacy recipe provides a formula that yields 120 grams of coal tar ointment. You are asked to prepare 30 grams of coal tar ointment. So right here, you're reducing the amount. So you're going from a larger to 30 grams. By what number do you need to divide each ingredient to make the desired formula? So again, you would, what you want would be on top. So 30 divided by 120 will give you 1/4. So that means that you're going to divide each formula by 4 in order to get your desired amount. So again, the answer is 4. Now it says the following pharmacy recipe provides a formula that yields 30 vaginal suppositories. You are to prepare 150 vaginal suppositories. By what number do you need to multiply each ingredient to make the desired formula? And again, here it's asking us to multiply because we're going from a small number to a larger number. So we're going to have to multiply all these ingredients to get the larger number. So again, we would put what we want, which is 150, divided by what we have, which is 30, and that gives us 5. So we're going to multiply each ingredient by 5 in order to get our desired amount. So this concludes the PowerPoint presentation for this section. Let's go ahead and review some of the problems on page 240 and 241. Okay, so let's go ahead and look at problem number 5. If I could get you guys to see it. Darn it. Hate when this doesn't work with me. Ah. Sorry about this. Okay, here we go. So it says, darn, the following pharmacy recipe provides a formula to prepare one 30 ml dropper bottle of Oticaine. You are to prepare 4 15 ml dropper bottles of Oticaine. State how much of each ingredient you will need to prepare the entire batch, round to the nearest tenth of a gram. Okay, so in pharmacy stock, formula yields 30 mLs. We have antipyrine 1.8 gram, benzocaine 0.5 grams, and glycerin quantity sufficient to add 30 mLs. Okay, so let's go ahead and go to our whiteboard and go over this problem. So according to what we have, it says that the formula yields, sorry. So the formula yields 30 mLs. We have antipyrine 1.8 grams, and we have benzocaine 0.5 grams, and we have glycerin QSAT 230 mLs. And we want to make 4 syringes of 15 mLs. Okay, so we need to find out the total volume. So we're going to go ahead and multiply 4 times 15 to make enough. So 4 times 15 is 60 mLs. So the quantity we want to make is 60 divided by the quantity we have, which is 30 mLs. So that is equal to 2-to-1 ratio. So that means we're going from a smaller amount to a larger. So we're going to have to multiply each ingredient by 2. So if we multiply 1.8 times 2, we get 3.6 grams. If we multiply 0.5 times 2, we get 1 gram. And if we multiply 30 times 2, we get 60 mLs. And that's what we want, right? Because we want 4 syringes of 15 mLs. So that means that we have our final result would be 3.6 grams of antipyrine. We want 1 gram of benzo. And we want 60 mLs quantity sufficient of glycerin. And that would be our answer. Okay, the rest of the problems, I believe they're for homework. So go ahead and work on those. And again, if you have any questions, please feel free to send me a message. Thank you, and see you in the next video.